Passive components, circulators, series on microwave engineering, lecture number 3.15. Circulators are multi-port, non-linear, non-reciprocal devices widely used in radar systems. Three ports are quite common in these devices, and more than four ports are quite uncommon. They employ ferrite rods for their operation. They accept power at one port and divert this power to another specific port. These are different from junctions, microwave junctions. In junctions, power division takes place, or power combining, waves combining takes place. Here in circulators, there is no division, there is no combining. It is just accepting power at one port and delivering it at a specific other port. In the present session, circulators, they are introduced along with their design aspects, along with their functionality, along with their merits and demerits. Now let us move further into the core session where we can have a deeper and more clear understanding regarding circulators. A few introductory points or statements regarding circulators are apt to begin with. Circulators are multi-port, lossless and non-reciprocal passive microwave devices. These are widely used in radar systems. They usually consist of three or more matched ports, but devices with more than four ports, they are quite uncommon. Symbol of circulator is also given here. In fact, two symbols are given, one in A, another in B. Each one has an arrow indicating certain rotation along with port numbering. In A, the rotation is in anti-clockwise direction. In B, rotation is in clockwise direction. We are going to learn about it soon, but to explain or to give some preliminary information regarding the arrow here, meaning of arrow in the symbol, it is required to mention that in A, the symbol indicates that port 2 is connected to port 3. Port 3 is connected to port 4. Port 4 is connected to port 1. 1 is connected to 2. So the connection is in anti-clockwise sense. In B, port 2 is connected to port 1. Port 1 to port 4. Port 4 to port 3. Port 3 to port 2. The connection is clockwise. After symbol, let us move further. They allow the power flow only from one port to another single port. The power flow is possible neither against the rotationality nor to more than one port. These are two features, special features pertaining to circulators. The necessary non-reciprocal behavior is usually achieved by incorporating ferrite rods with proper bias into the structure. They can be divided into two anti-clockwise devices, clockwise devices, or anti-clockwise rotational devices and clockwise rotational device. The symbols of circulators with opposite rotationality, they are different. Symbols are different. The port numbering can be clockwise or anti-clockwise. The two aspects must be kept in mind. Rotationality and port numbering. A device may belong to anti-clockwise rotationality or clockwise rotationality. A device may be numbered anti-clockwise or clockwise ports of the device. If both the rotationality and port numbering, they are reversed simultaneously, then ports between which power flow take places remain unchanged. If these devices require a change of rotationality, then how it is achieved? There are two methods. By adopting either one, rotationality change is achieved. One is transposing the port numbers. Another is changing the polarity of the bias field of the ferrite rod. Usually, the second method is used in practice. A three-port circulator is also used as an isolator by terminating one of the ports with a matched load. From the nature of power flow in circulators, their S matrices can be easily derived. For an ideal three-port circulator with clockwise rotationality and anti-clockwise port numbering, the matrix appears like this: 0, 0, 1, 1, 0, 0, 0, 1, 0. The scattering matrix remains same when both rotationality and port numbering are changed simultaneously. The rotationality to anti-clockwise, port numbering to clockwise. Here the matrix is for clockwise rotationality, anti-clockwise numbering. It remains same. Matrix is the same for a device with anti-clockwise rotationality and clockwise numbering. Now we consider a circulator, Faraday rotation circulator, and try to understand how it is able to provide the functionality of a circulator. The structure of Faraday rotation circulator consists of a length of circular waveguide with two transitions at the ends. Transitions are waveguide pieces with different openings. One opening is rectangular, another opening is circular. Transitions are used mainly for the purpose of providing a connection between the rectangular waveguides and circular waveguides. In the present structure, two transitions exist and two rectangular waveguide pieces over its body. A ferrite rod inside the guide body along with its bias magnet. These are all parts of the circulator. There are four ports for this device, two end transition ports 1 and 2, and two rectangular side ports 3 and 4, placed with their broader walls along the length of the waveguide. Basically, it is a four-port device. Two ports are associated with the end transitions, and two ports are associated with two rectangular waveguide pieces. The ports 2 and 4 are twisted towards the observer by an angle of 45 degrees from ports 1 and 3. Twist. What is the purpose of twist? Twist is a passive component. If we consider a piece of rectangular waveguide, ordinary rectangular waveguide, its ports, it has two ports. Its ports, you can find them parallel to each other. This is the case with ordinary rectangular waveguides. But in twists, there exists certain angle between the ports. The guide is twisted so that the ports have certain angle between them. They are no more parallel. In the present situation, twists which have an angle of 45 degrees between their openings, they are used. Twists serve the purpose of rotating, changing the orientation of electric vector in the wave. The circular waveguide is capable of carrying wave in the dominant mode TE11, and the rectangular ports 1, 2, 3 and 4 can hold the corresponding dominant wave TE10. Dominant mode in circular waveguides is TE11. In rectangular waveguides, it is TE10. Here is shown the structural features of Faraday rotation circulator. In A is shown its a symbol. From the symbol, one can notice that it belongs to the rotationality of clockwise. Therefore, 1 is connected to 2 is connected to 3, 3 is connected to 4, 4 is connected to 1. Or 1 is connected to 2 only, 2 is connected to 3 only, 3 is connected to 4 only, 4 is connected to 1 only. How this functionality is achieved with the structure that is shown in we see right now. To understand the functioning of this particular device, we have to keep one important aspect in mind. Waves, they are associated with a certain structure. It is called mode. Guides, wave guides, they are also associated with certain structure, physical structure. A wave can exist into the guide only when their structures are compatible, only when their structures are conforming to each other. If the structures are not conforming each other, are not compatible to each other, then the wave can neither enter nor travel to the guide nor sustain in the guide. This aspect has to be kept in mind. Then only one can understand the functioning of devices like Faraday rotation circulator. Okay, let us begin with identifying ports. Port 1 is in the transition, input side transition. Port 2 is in the output transition. Notice port 1, port 2, they are not parallel. They are making certain angle with each other. It is 45 degrees in the present case. In between the transitions, there is a circular waveguide. The circular waveguide contains a ferrite rod. The length, the thickness, the bias field, all that they are selected in such a way that the ferrite rod gives a rotation of 45 degrees to the wave. In addition, these items one can find two pieces of rectangular waveguide. They are connected, they are pasted, they are glued to the body of the circular waveguide. Their ports are 3 and 4. Notice before connection, some hole or slot is made over the wall of circular waveguide, and then the pieces are attached to the circular waveguide. So there is a coupling. There exists coupling between circular waveguide and rectangular waveguide pieces with ports 3 and 4. Also notice there exists an angle 3 and 4. These arms, they are not parallel to each other. They are not in line. There is an angle between them. It is set at 45 degrees. The ferrite rod provides 45 degrees rotation. Twist is there in the outside transition. It provides 45 degrees rotation. Arms, rectangular waveguide arms, they are also having an angle of 45 degrees between them. Now, after having some idea on the structural features of the device, now let us move to have an insight, an understanding regarding the functioning of the device. We begin by considering a wave input at port 1. We also consider the input wave as one in dominant mode. Now the wave enters, it travels like this. In the wave, electric vector is vertical from one broader wall to another broader wall. While traveling, the wave comes across the arm with port 3, but it gets unaffected by the presence of this side arm. Reason is this arm is not compatible with the structure of the wave. So it can no way influence wave propagation. Notice in the arm with port 3, walls are vertical, field is also vertical. Then how field can be sustained in this structure? For the field to exist, there should be two walls, two plates to originate the field, to get terminated by the field. But we don't have any horizontal walls in this arm. Therefore, unaffected by the presence of the side arm, the wave travels, then enters into the ferrite rod region. There it gets a rotation of 45 degrees towards the observer, and then the wave moves further. There it encounters a side arm with port 4, this one. For the same reason, the reason because of which it is unaffected by arm with port 3, here also wave gets unaffected by the presence of arm with port 4, and then it moves further and reaches port 2. Notice before reaching port 2, the electric vector, it was rotated by the ferrite rod by 45 degrees. And the twist in the output side, it also gave a 45 degrees rotation to the port 2. As these two rotations are in the same direction, now the wave can come out of the port comfortably without any problem. So when input is given at 1, it comes out of 2 without any problem. So 1 to 2 connection. We consider another situation. If input is given at port 2, then the wave travels. It encounters, of course, side arm with port 4, but because of structural incompatibility, wave gets unaffected by its presence and then travels, then encounters ferrite rod. Ferrite rod gives 45 degrees rotation towards the observer. So in the beginning, if electric vector is like this, after traveling past the ferrite rod, electric vector becomes horizontal. 45 degrees plus 45 degrees. 145 degrees by the twist, another 45 degrees by the ferrite rod. Now horizontal. The wave travels further, and now it encounters side arm with port 3. Notice this arm now is compatible with the wave. This is the port, and electric vector is this. Normal to broader walls, parallel to narrow walls. Compatible. Compatibility is there between the arm and wave. So hence wave can travel into the arm and can come out of the port 3. This is the case with most of the wave. A little bit of the wave may escape and travel further towards port 1. But port 1 cannot support the wave whose electric vector is parallel to broader walls. The wave that reaches port 1, in that wave, electric vector is horizontal. So wave is not compatible to the port. So wave cannot come out. The fact is, in reality, most of the wave comes out of 3. If the design is good, perfect, then nothing comes out of port 1 or port 4. In the same way, we can analyze the situation where wave is given at port 3 and port 4. We have seen when wave is given at port 1, it is appearing at 2. When input is given at port 2, it is appearing at 3. If you give input at port 3, it appears at port 4. If we give input at port 4, it appears at port 1. So the structure that is shown in B, it is able to provide a functionality which is essential for it to be called a circulator. Now let us have a description of the working of the device in a more clear terms. A thin ferrite rod is placed inside the circular waveguide supported by polyfoam, and the waveguide is surrounded by a permanent magnet which produces the necessary DC magnetic field to bias the ferrite rod. The bias is such that the rotation of the electric vector is always towards the observer, independent of direction of travel of the wave, either from 1 to 2 or 2 to 1. To understand its functioning, consider a wave fed at port 1 which passes past the port 3 unaffected, as its electric field is not cut significantly and without entering into it, as the electric field is normal to the port. Note that wave can exist in the port, enter into the port or come out of the port, or in other words, can be supported by the port only when the electric vector is parallel to the side walls. This is what we are terming it as a compatibility between structure of the guide and structure of the wave. The electric vector of the wave then gets rotated 45 degrees by ferrite rod, continues traveling past the port 4 without entering into it, ultimately reaching the port 2. When the wave reaches port 2, its electric vector is normal to broader walls and parallel to side walls, as both wave and port have a twist of 45 degrees in the same direction. The wave now can comfortably emerge from port 2. A wave given at port 1 appears at port 2 only and nothing at any other port. Now consider a wave fed at port 2. It travels past the port 4 unaffected and without entering into it, as electric vector is normal to the port. The electric vector of this wave then can gets rotated 45 degrees by the ferrite rod and reaches the port 3. As the orientation of electric vector is suitable, the wave emerges from the port 3 completely. Even if a small part of the wave reaches port 1, it cannot come out of the port 1 because in this case electric vector of the wave is normal to the side walls and hence port cannot support the wave. Hence wave given at port 2 appears at port 3 only, nothing at any other port. Similarly, it can be shown that port 3 is coupled only to port 4 and port 4 only to port 1. So far, it is about the functioning or working of the device. Now, a few points regarding merits, demerits, and all that. This type device suffers with certain limitations. Most serious one among them is that it is not well suited for high power applications. Hence, it is power limited and eminently suitable for low power applications. It is also bulkier, restricting its use to highest frequencies in the millimeter range and above. These are the things which I want to share with you for right now. To recap, the device circulator, it was introduced then rotationality, the concept of rotationality which is specific to circulator. It is then described. Faraday rotation circulator, its structural features, its functioning, its limitations, all are then explained elaborately. Hope you have a beautiful, wonderful, fruitful, successful, transforming deep learning experience. Enough for now. See you again soon in another session. Bye bye.